Okay, guys. So, at the very beginning, I just want to say, well, let me read this. It says, at what values of x does the graph of this have a point of inflection? All right, so we're going to need, so for a point of inflection, we're going to need a sign change on the second derivative. Okay, so y double prime. So we got to find the second derivative. And then we're going to use the number line. Now, guys, when you use the number line test, on the number line always goes the critical numbers. And the critical numbers are where the derivative is 0 or undefined. Now, sometimes we're using the critical numbers on the first derivative, sometimes we're using them on the second derivative. So since we're looking for a point of inflection, which has to do with a sign change on y double prime, the critical numbers we're looking for are from the second derivative, and it's where the second derivative is 0 or undefined. So we got to figure those out, put them on a number line, look for a sign change. Okay, so the first derivative, well, actually, before I do that, I'm going to rewrite this as x to the negative 2 minus x to the negative 3. So I could use the power rule. So ax to the n. I want terms of that form, so I could use the power rule. So y prime is negative 2x to the negative 3 plus 3x to the negative 4. Now I need the second derivative. So that's 6x to the negative 4 minus 12x to the negative 5. Now we've got to figure out where is this 0 or undefined. Now, guys, in order to do that, it helps to have this put back in like fraction form, in a single fraction even better. We practiced this a lot last year. It's okay if you're rusty though. So 6x to the positive 4th minus 12x to the positive 5th. Let me get common denominators. So I multiply this by a single factor of x. So I've got 6x minus 12 over x to the 5th. Okay, so critical numbers, this is the second derivative. So critical numbers that we're going to put on the number line are where this is 0 or undefined. So y double prime equals 0 for when the whole fraction equals 0, which is when the numerator equals 0. If you imagine setting this equal to 0 and cross multiplying, it's just the numerator that you care about. So x equals 2 is a critical number. And then y double prime undefined for x equals 0. For the undefined part, you set the denominator equal to 0. That's when it's undefined. So then I put these, y double prime, I put these on the number line. Okay, 0, 2. Okay, I can plug in negative 1, I can plug in 1, I can plug in 3. If I plug negative 1 into the second derivative, I get a negative over a negative. That's a positive. If I plug 1 in, I get a negative over a positive. That's a negative. If I plug a 3 in, I get a positive over a positive. That's a positive. So guys, it looks like we have sign changes at both of these, 0 and 2. And if you look here, they're both options, 0 and 2. But guys, here is the thing. If you were, say that you were finding the point of inflection, you know that the points of inflection are going to be 0 comma something and 2 comma something. And where would you plug 0 and 2 in to get the y coordinates? Guys, points of inflection are on the original graph. So you would plug these critical numbers into the original to find the points of inflection. But guys, look at 0. If you plug 0 in here, you're going to be dividing by 0. If you plug 2 in here, you're going to get a number. But if you plug 0 in there, you get something that's undefined. And here you would get an actual number. So it is 2. That's the one that is where we have a point of inflection. So it turns out, guys, that an input of 0 is not even, that you can't even do that here. Okay, so the critical numbers are not always going, the critical numbers are not always going to correspond to a point of inflection. They're just the potential points, the potential numbers where the points of inflection occur at.